Hello everybody, this is paper 1 from May 2023. This is time zone 2. Good question, kind of challenging. Alright, question 10, 8-mark question, one of the bigger questions on this paper. Here we go. A player throws a basketball. The height of the basketball is modeled by h of t is equal to negative 4.75 t squared plus 8.75 t plus 1.5. So height as a function of time. We input different values of t and we get the height at a given point. It's the height of a basketball and we're going to throw this basketball. So already we can imagine that we're going to have a quadratic, which is good. So h is the height of the basketball above the ground in meters, and t is time in seconds after it was thrown. Find how long it takes for the basketball to reach its maximum height. So we've got a function already which relates height and time. I think the most straightforward thing to do would be to graph this function and then find out these features. So let's go to the calculator screen and work this out. Let's get a new document and add a graph. So here is our function, negative 4.75, and of course we need to write t as x. So x squared plus 8.75 x plus 1.5. Negative 4.75 x squared plus 8.75. Alright, and very kind of generous question. We don't have to change any of the window at all. Let's analyze the graph and let's find its maximum. Okay. So the highest point, this is height against time. The highest point the basketball goes is 0.921. I hope this is 921 meters after 5.5. Oh no, I'm sorry. Thankfully that's not the case. X is our time, Y is our height. After 0.921 seconds, we're 5.53 meters in the air. That's reassuring. Okay, how long it takes a basketball to reach its maximum height? 0.921 seconds. So let's go back to the document here. Part A. The question itself isn't bad, but it's a 2-mark question, so we would need to provide some kind of process. And so a sketch would be fine, and to be honest I think that's going to be the easiest thing. So here we go, here's our highest point, and it happens at 0.921, and that it's 5.53. And so our answer, how long it takes, 0.921 seconds. Just be careful, 2-mark question, they're going to want a sketch. Assuming that no player catches a ball, find how long it would take for the basketball to hit the ground. This is part B, and once again, we already have the graph. This is going to correspond to the point at which h is equal to 0. So 2 different ways we could work this out. I think since the graph is already open, it would be somewhat straightforward to just find this value right here where we intersect the x-axis. But essentially we could also say, okay, if we have this function h of t is equal to, what is it, negative 4.75 t squared plus 8.75 t plus 1.5, we can just ask, okay, well, whoops, if h is equal to 0, what is the value of t that makes this true? And then you could essentially just end solve this for t. Just be careful, end solve sometimes gives you the closest point to 0, and so it might actually give you a negative point, which doesn't make sense. That would be incorrect. We'd want to find this positive value here. Okay, I'm actually going to work it out graphically. So going back to the calculator screen, let's go Menu, Analyze Graph, and let's find the 0. Alright, after 2 seconds, the basketball has a height of 0. So let's go back to the document here. Alright, let's label the graph. This is going to be process marks 2, 0, and we might say after 2 seconds. Okay. Another player catches the basketball when it is at a height of 1.2 meters. Find the value of t when this player catches a basketball. Okay, so here we are. Here's our function once again, and I think this is a great question just to continue to solve graphically, but just to kind of show what's going on here. So here's our basketball height as a function of time. And what is going on here is there's someone who's going to catch this ball when h is equal to 1.2 meters. And so they catch this ball. We want to find the time at which this player catches a ball. So this would be a dangerous one to use nsolve, because nsolve would only find the first value. But it'd be unlikely for this player to catch the ball on its way up. That wouldn't make a lot of sense. So really, we're looking for this point right here. Alright, find the value of t when this player catches a basketball. There is some ambiguity. I don't think there's anything specifically in the question that says that it can't be on its way up, but it doesn't really make sense. Alright, so let's go to the document, rather the calculator, and let's create another function. So Menu, Graph Entry, Function, and let's put a value of f of x, or essentially just y, is equal to 1.2. Alright, and we want to find the point at which we intersect. So Analyze Graph, Intersection, and actually we would be okay in this instance because it looks like it's negative, so that wouldn't make sense. And so we're just interested in this point right here, this 1.88. After 1.88 seconds, the ball is 1.2 meters in the air. So let's go back to the document and let's write that in. So we have a value 1.88 seconds. The calculator, the basketball is 1.2 meters in the air. Okay. Find the value of t when this player catches the ball. T is equal to 1.88. You can write after 2 seconds, but all the same you can write t is equal to 2 for each of these questions as well. Okay. Part D, write down 2 limitations of using h of t to model the height of the basketball. So remember, h of t is actually just what we're calling this function. So what are some limitations of using this function right here to model the height of the basketball through time? So that's what h of t is, this function up here. So what are 2 limitations? What are 2 limitations? Real world question, potentially, it ignores air resistance. It ignores air resistance. Second limitation is, if we look at our models, for example, what they also do is they also consider points that occur. Our model doesn't have any, it has a value of t is greater than 0. So it doesn't deal with, let's say, negative values, which is positive, but for t greater than 0, it would assume our ball goes through the floor and so on, keeps going down. So does not consider, let's say, ball bouncing. or hitting the ground. Hitting the ground. The ground. Actually, look at the mark scheme earlier, and it also has things like it assumes gravity is constant, which by and large it roughly is, or enough that, to be honest, it wouldn't be a major consideration if you're just considering a basketball, flying through the air. But what it did say is that do not accept generic answers. Do not accept generic answers of generic criticisms of a mathematical model, such as there are assumptions being made, or models are never accurate. So it has to be specific. Alright. Okay, so really not a bad question actually, especially if you're comfortable with the graphing calculator and graphing tool.